My name is Percy French. I'm the engineering manager at Sibanye-Stillwater.
Sibanye-Stillwater is a multinational mining and metals processing group with a diverse portfolio of operations, projects and investments across 5 continents. Our South African PGM operation, located in the Northwest Province, comprises of mining, mineral extraction, smelting and refining facilities that extend over approximately 55 to 60 kilometers.
I'm Sbusiso Masego. I'm the unit manager for control and instrumentation. I manage the strategy, the performance and the development of control systems as well as control and instrumentation systems. So the main goal for this project was to replace our legacy systems which have reached near end of life, as well as to modernize our SCADA graphics and to create a system that is resilient and not vulnerable to any cyber threats.
My name is Johan Lowe. I work as a technical specialist at Sibanye-Stillwater. I'm part of the group technical team. Here at Sibanye, we believe in digital as a form of operational performance. So originally Ignition was implemented to replace the legacy SCADAs, but Ignition is much more than that. It's a true platform of which a SCADA only forms a small part, and the rest of the platform is just possibilities.
The key requirement is that we should implement an operational technology that is a workable solution to integrate various products and requirements from our operational teams, from SAP ERP systems all the way to lab information management systems.
The customization with Ignition made it easy for Concera to understand our requirement and the need for this project.
I'm Rolf Boshoff. I'm the co-founder, director and engineer at Concera. I believe I'm the first true believer in the company who believes in Ignition and what it can offer. Sibanye required a distributed control system, basically the visualization for their current PLCs on site. These operations included 4 shafts and 10 compressors. We wanted to create a system that's not only easy for the operator to use, but is easily used by maintenance teams to expand the system and maintain it and make their life easier as well.
It must be a simple system that is easily understandable and simple implementable, to also be in line with our PLC coding standards without hindering our current operational systems.
Where we initially estimated 4 to 6 months to create the full project, we were asked to do it within 8 to 10 weeks. We were able to build tools and standards to use in such a way that we can deliver on that promise and deliver fat-tested software by the due date. Ignition provides a flexible OT platform where we can use multiple elements like flexible data structures to Python coding to build elements that we can easily reuse and auto-populate data where required.
Another feature was UDTs, which enables the creation of PLC standards or customized standards, and that actually fitted exactly with our PLCs. With this system you can actually roll out hundreds of thousands of tags in a very short period up to a standard, and it's of good quality.
We had 3 different PLC standards that we had to cater for on site. We built templates that could easily be modified and utilized no matter on this tag structure in the PLC, and that made our development process that much quicker. The flexibility and versatility that Ignition and Perspective offers through their Python scripting and versatile data structures allowed us to create sophisticated visuals. One of these visual elements is the compressor surge curve, which visualizes the proprietary compressor control utilized within the compressor PLCs. This controls essential to the operation of the compressors to make it work effectively and efficiently. The Sibanye implementation of Ignition was originally used for visualization, but since then it's expanded to a proper OT platform. We're using the Ignition more as data collection, distributing that data to relevant parties, and not just in visualization, but also in forms of reporting and dashboarding. In the end, the project required the use of about 500,000 PLC tags. It had 160 displays or separate views for visualization. We historized about 7,000 tags and could generate up to 12,000 alarms on the system.
We had to embrace the ASM or Abnormal Situational Awareness Standards. It's often referred to as the grayscale SCADA, and then color is used to do the highlight. The SCADA basically uses the color to empower the operator to do his work more efficiently, and you can control what he needs to focus on.
The Abnormal Situation Management Standard has very specific requirements. Firstly, the one is the use of a navigation tree. Secondly is not using any pop-ups, not obscuring the view of the SCADA for the operator at any times. We utilize the tag provider as our central repository of data, enabling security, alarming, and navigation information into one repository. It auto-generates the tree. We are able to specify which views open up based on what element you click on, which faceplates are opened. It goes as far as setting security up to instance level. We further use the tree element to ensure navigation happens in a standard manner. The auto-generated navigation tree allowed us to make the navigation predictable and simple.
Concera customized the tree view up to the point where we could actually lead the operator, like with breadcrumbs, through the tree view up to the point of abnormal conditions.
We introduced a lot of quality of life features. For example, like docking certain analog or PV values on the right side of the screen that's always visible no matter what page you are viewing. We implemented some search algorithms on the tree so you can filter on certain text or areas. We even allowed a forward and backwards on pages. So if you don't want to click on the tree, you just want to go back to the previous page or previous faceplate. We brought in a lot of quality of life features that just made the system more usable.
Another big feature was EAM, which enabled us to actually implement our architecture solution and enterprise style architecture.
We utilized enterprise administration module and project inheritance to ensure that standards were driven within these disparate systems. With the use of a hub and spoke model, we were able to create a central repository of the standards that we can then distribute to all the relevant gateways on the network. We used EAM as a way of managing standards and distributing projects to different servers. We used Historian to store data for analytics and fault finding, and ultimately also used MQTT to distribute data to the Canary Historian for production data storage. We then used the hub also as a main visualization server with unlimited views for Ignition, where anyone on the IT network could get access to the visuals.
The unexpected benefit of Ignition to me was the data buffering during network loss or network outages. We had quite a few challenges with compressors being in remote locations. Whenever we had network outages, that actually affected the central control room not having visibility. Whenever we have network loss, we couldn't historize on what's happening on the compressor machines locally. So that has been solved by Ignition, by the local edge gateway servers.
The fact that you can actually recover from a major disaster, half an hour we could reload a complete system. Ignition currently is the solution that is technologically up to date and is the perfect platform to take you into the future.
Our legacy systems were vulnerable to cyber threats, and they had already reached near end of life, which made it difficult to improve and implement as well as comply with the international standards.
On the Sibanye project, we followed security best practices like using Active Directory authentication for user authentication, using roles to provide access on certain elements within the visualization. Those elements could be locked down up to instance level, so we allowed for flexibility. and make sure that the operator has the right access when required. We limited the ports to the IT domain based on what is required. In the end, only 2 ports were required to be opened, which makes the system very secure. And SSL certificates was enabled on all IT infrastructure.
It's actually much more secure than our legacy system and very much customizable to our requirements. And we keep on discovering new features as we keep using the product.
One of the big outcomes that I'm actually quite excited about is the web-based technology. We could basically bring information, SCADAs, whatever we needed to the decision makers. The cost of implementation was probably less than what we currently pay on our support costs. Taking this forward, the cost saving would actually just become more exponential.
One of the key features of the product was the long-term cost of ownership, especially with the perpetual license, including your dual redundancy license at a 50% rate in some of our operational areas where uptime is of key importance in mission-critical systems.
Ignition is lightweight and not resource intense, and the engineering cycles are quicker. You don't need specialized teams to support Ignition.
We are also starting to introduce equipment monitoring systems, which is moving machinery, which also needs to report specific information to our operational teams within our control rooms as well as our maintenance teams. The capability of having immediate view once we've initialized a change, that basically ensures that we've got an improvement in our engineering efficiency.
Concera was not only a vendor to us, but a partner. Their expertise, their knowledge on the system made life very easy. It has been an amazing journey, an amazing project. It actually shows that, how much more that we can do with the solution that we have.
In the past, we used to spend a lot of time on fault finding the product and not the solution. And I think that is time wasted. With this new Ignition platform, I think if you can dream it, you can build it.